In this video, we'll show you the bootstrapping and evaluation process. Bootstrapping and fixed-point validation consist of three parts. First, we create the Genesis hard-coded graph. Second, we validate the parser. And third, we validate the phraser and the symmetry. And if all goes well, the results will show that all the states we generated are the same. Phonal itself was developed in NetBeans and consists of several libraries. The Chi library controls the network. The grammar library controls all the methods associated with the syntax. Then we have the extensions such as expressions, etc., the communication library, and finally the server. In this part, we'll only use Chi and the grammar. Let's start with the Chi. We start with an empty graph. And the first command is create. Well, we now create a new network. For that, the program calls build Java. What has he done? He has created 173 symbols and connected them to each other with the classification relationship. And you can clearly see here how that happened exactly. This is, so to speak, the first result. Then we have the subject here. That's the spider in the whole thing, so to speak. And these are other subjects. This is, I believe, the subject keywords. And these are the operators, but we'll come back to that in a moment. So, the next step is that we not just have the spider structure, but also the names and identifiers. And that happens in this part. So, if we let it continue now. This takes a while because it also has to do the hash tables with about 200.000 entries. Then this is the result of the second loop. We still have 173 starting symbols, but now because we've added the names and so on, we also have a lot of non-terminal symbols and non-terminal relationships. The result, can you see here? So let's make this window a bit bigger. See the spider subject again here. But now there's a name and an identifier each time. These are, for example, 46, which are all the operators. You can see them here. These are, for example, all the keywords. And you can see them here like this. This is essentially the basic lexicon for the next step. We're now moving on to the second part of the hard-coded graph, and for that, we'll start the program main grammar. The graph currently contains the lexicon. What the next phase does is use a separate Java program that parses the syntax and thus completes the graph. The first thing it does is retrieve the syntax. We can take a look at how that works. This function retrieves the adjective phrase, the default phrase, the determiner phrase, etc. We can take a look at the sentence that defines the sentence. That's the utterance for the sentence. When the program has read this text, it will apply this function to it. That's the specific Java program that parses the string and adds it to the network. Now, this part of the program has been run, and this is the result. There are a total of 9,224 symbols. You can get an idea of what happened by looking at what the network structure looks like now. So, inside here is the lexicon. Based on the lexicon and the 10 sentences, the program has now created this network. We're now moving on to the next phase. And that starts here. Here we said that mutations are allowed. But we're going to do it again, namely to test Leibniz's identity principle. Because if we do exactly the same thing again, then, based on this principle, there shouldn't be any mutations. After all, you create a start symbol with identical attributes, then there shouldn't be any difference between the first and second parsing. That's why we now say no mutations allowed is true, so no mutations should occur during the second run. Well, then we'll let the program run. This is now the second time the program has parsed, and if you compare it to the previous time, you can see that there are exactly the same number of symbols, 9224 to 9224. Moreover, we didn't receive any notification from the system, because there's an explicit check here. The check mutation allowed function checks for each start symbol whether mutations have occurred, and if not, the identity principle is applied correctly. If it's wrong, it reports it here. And we need to look into the reason for the mutation. The Genesis graph is ready for the next step, the phonal parser validation. We now arrive at the part about self-parsing. All ingredients for self-parsing have been discussed. First, the Genesis graph. The network. All the information we need to parse the network is contained within this network itself, along with a number of methods. For each syntactic category, there are a number of polymorphic methods. There are 6 of them that are fully or partially applicable to the syntactic categories. The most important is the state-transforming method of parsing. Then comes the phrase method, which is used to express something in words. Then comes the evaluation method, which is used to test whether something is true. The collect method is used for retrieving information. Finally, the naming and recognition methods. These methods are all polymorphic. They are applied to all kinds of knowledge. You can find these methods here in the syntax. Here are all syntactic categories. Let's take the subject, for example. Then we can see how that works. The subject category applies to all methods. Parse body, evaluate body, collect body, phrase body, name body, and recognize body. These are the same as the ones we have here. This is the most complete one, along with the noun phrase. Let's start the program now. And then we'll stop it here. First, we'll instruct the system that mutations are not allowed. So, in principle, it should be like this. When we show the statistics here in a moment, it should result in exactly the same result as the statistics from stage 4. Okay, let's continue running the program. He's done with this part. This was the old state with the Java parser. Now we need to scroll down a bit. Here you see the result. The number of symbols is exactly the same, and we didn't receive any notification from the system that there were any mutations, so this part went well. Now we can move on to the next part, phraser and symmetry validation. First, I need to say something about those 6 methods. If you're going to parse, you need evaluating, collecting, and recognizing. If you're going to phrase, putting something into words, you need evaluating, collecting, and naming. And that's what's going to happen here. We can follow along and show the process sentence by sentence. Then you see the phrase result from the AP here, followed by the parse result. And that continues for each of these 10 sentences. Here is the proper noun phrase, and so on. Well, let's run that one too. The program is now running to its end, without interruption. This means that this last verification was also successful because no changes were observed.